Good morning, everyone.
And welcome to This Old App. So just a quick note, we're doing this because we're passionate about the industry, we're passionate about clouds. We're not particularly representing any employers, past or present, although they're generally supportive that we do this kind of thing.
Right, and we've been members of OWASP and support the community, and so we'd like to give some of it back.
Which gets us into why we're doing this. So here's a little bit about what we're going to talk about today. I'll just leave that for a moment. So why cloud?
Right, so if you're moving an old legacy app to the cloud, you have to ask yourself the first question as to why are you going to the cloud in the first place? Is it just hype? Did some salesman get a hold of you, or are you at a conference like this? And
I heard cloud was good.
Yeah,
we should do it.
Exactly. Or is your management telling you to do it? Or maybe you lost a golf bet or something. Anyway, there are better reasons to try to move your app to the cloud. And
better reasons?
Yes, better reasons. So we have things like technology evolution, agility.
I like that cost savings one.
Oh, no, cost savings is not the right idea. This is often the thing that people cite most.
That's not a thing, is it? No, not really.
No. And so after you've decided, why the cloud and that sort of thing, then, what kind of cloud? And since you're the cloud architect in the group here, why don't you lead us down
all right. Well, I like pizza. Anybody else like pizza? This is a pretty good analogy that somebody else put together. Actually, one of the things we're trying to do, I see other people doing it too, is include references to stuff, because we believe in citing our sources. So if we missed one, we apologize. Unfortunately, this model is a great idea, but it's wrong, and somebody fixed it. So the difference is that in the other one, like for IaaS, all the things that you bring yourself are kind of backwards. Like, if it's infrastructure as a service, you wouldn't be using your own oven, would you? So somebody fixed it.
It's the beauty of the internet.
It is. We are all smarter together. So here's just a quick survey of clouds, some different clouds that are out there for some of the different models. NIST talks about public, hybrid, private, and community. Pretty much if you're not using GovCloud, community is not a thing. If anyone's got a counterexample to that, or something I ought to add to the community clouds that do exist, be glad to add it. So how do you choose? Public has a lot of appeal. You might notice that I have an opinion about hybrid.
It does look that way.
Yeah, well, hybrid's a great way of performing unnatural acts on the cloud.
Unnatural acts. Well.
Yeah. So clouds are inherently disruptive. They were created by developers to solve the problem of delivering value quickly. All of our classic data center problems, like change is bad, change is scary. I changed something and now I have a cascading failure and lots of things don't work. Everyone hates change in the data center. Clouds are meant to make change easy, fast, reliable, and if we do it right, secure. So it turns the security model upside down, because now speed is your ally. Fast things used to be the enemy of security. But now, if you can patch faster, if you can respond faster, if you can quarantine faster, what do we have to be afraid of? Oh, and by the way, you want to know all your assets? There's an API for that. Just ask. It works. So you have to change the way you think. There's a lot of great control frameworks and models. And then there's the implementations of them that are just traditional, right? They have all the classic expectations. And if you try to apply that to your cloud, man, not only will you get all of the benefits of moving slowly from your data center, you'll also probably force your cloud to do things that actually make you less secure. So don't do that.
And the truth is, some of these control frameworks have to evolve with the cloud and take into account the cloud. I mean, you look at some of the things like PCI and HIPAA and things, they're already starting to go down that road in their next evolution.
Oh, that's a solid point. So this is, under the updated approaches, this is actually a set of bullet points from devsecops.org, the DevSecOps Manifesto. And this is about the change in mindset, changing the way we think. So, is my app a candidate for the cloud?
Well, that all depends on what your app is.
Well, how about this one?
Ooh. No, that probably is not a good candidate for the cloud. That looks like quite the monolith right there.
All right.
All right, so I would have to say to you, stop. Do you really know what you're thinking here?
No, I'm just up here talking.
All right, well, since we are architects, we really like patterns and architectural patterns. And when we talk about architectural patterns, what we mean is that we're talking about something like the Gang of Four patterns that are enterprise architecture patterns. They, typically have a name of the pattern, a problem that you're trying to solve, the solution for that problem, and then any sort of consequences and things. And from our standpoint, some of those consequences are security consequences, since we're security architects. But that is for software development or software architecture. We're trying to do this, apply patterns to cloud migrations. So we need to, in the spirit of the Gang of Four and that template that I just showed a minute ago, we're going to present a few possibilities for migration patterns. So that's a migration pattern. So the first one is
But monoliths are non-migratory.
yes, they are, but we're going to try to break that up and try to make sense of it. So you got the legacy app. Your cloud purist is going to look at that and say, well, if you want to move that to the cloud, you need to componentize your app into its smallest pieces, convert and refactor all of that to microservices, and then you'll live happily ever after in the cloud. While that does sound good and is really probably idealistic, it is also the most disruptive and risky to your app in terms of where it stands today and where it needs to be as part of the migration. The other thing is, unless you've done this sort of thing before in terms of refactoring and converting things into microservices, you're likely to do it wrong. Just because you learn a lot through the process of just your first migration and deployment into a cloud environment. Now, the second pattern is the forklift. This is what all the business people and the people want to do. They just want to take your existing app, pick it up, and slap it down onto the cloud. And that just usually can't work in a typical monolithic app type environment where you have a single stack of, a web server, app server, database server, all living together in a stack, which with all of its dependencies to things. You might have directory services and databases and other web services that this monolith is talking to. So you can't just lift it up, stick it onto the cloud, and call it done. You have to account for all of those interdependencies that the app has.
And that's where you potentially get into unnatural acts, like expecting cloud things that were never intended to keep state, or have reliable session, because, clouds are inherently designed to be resilient to failure, but that means that you're riding on top of the thing that's going to replace the things underneath you. And if your app can't handle that, poof, there went your state in the middle of interacting with a client.
Right, so I mean, we don't want to be in the business of creating a bunch of other dependencies in the cloud just to make our single app work, right? So we want to think a little bit more creatively about that.
Indeed.
Which leads us to my last pattern here, which is break it till you make it. So this is basically, you take your app, you throw it into the cloud, you see what breaks, and then you systematically fix the pieces until you have a working, running app in the cloud environment. There are some inherent risks to this approach too, because you are not properly decomposing your application into its components and converting them into microservices, but you are learning how the cloud works and how your interdependencies relate to the cloud you're trying to deploy to and your app.
Yeah, one of the great things about this is that you're not engaging in the fiction that you know how to decompose your app to make it work in the cloud if you haven't done this before, right? So I've got a case in point of a particular app where the team knew they needed to move out of a data center. They spent some time planning a decomposition to move it into a cloud, and one thing led to another, and they said, you know what, we've just got to push and try to forklift this thing and just fix what breaks. So they ended up in the break until you make it pattern. And when we talked about it with them afterwards, they said, you know what, our assumptions were all wrong. I'm glad that we went and tried to put it in the cloud and try that first and see what breaks. Because if we'd spent all the time investing in decomposing it and doing it the way we thought, we'd have been wrong. We'd have wasted a bunch of time. We'd have made some wrong assumptions. This is a great way to learn. But the important safety tip here is once you've successfully put it in the cloud, don't think you're done. Now you've got an app that you can actually deploy to the cloud. Now you've got a bunch more work in front of you. But it's a way to make sure that you do the learning as you go.
So another way to think about this, I mean, from a software architecture point of view, you could make an argument that the first pattern I showed, which was the decomposition pattern, is more of a kind of waterfall method of architecture, whereas this is more of an agile methodology.
It is.
Because you iterate and fix as you go. So there is some prior art in this space. I mean, it's not just us inventing patterns. Martin Fowler of Game of Four fame did kind of invent this strangulation pattern, and it's specifically for dealing with monolithic applications and deploying them into the cloud and developing a methodology for that deployment and for the refactoring. And so what he suggests is that you have a monolith application, it has clients, and those clients have, or the monolith has functions that the clients are trying to access, so basically services. And what Martin suggests is that you build a RESTful API layer on top of your monolith to interact with an adapter that can convert whatever your clients are used to in terms of protocol or communication into RESTful-based services over HTTPS. And by doing so, you can then concentrate on each of your functions and do a refactor into a microservice, which leads to the elimination of that function from the monolith. But you can keep the two systems operational, the microservice and the leftover legacy system in the same cloud environment as you refactor.
Yeah, one of the cool things about this is that it opens up the door then to adding new clients that talk to the monolith via that API abstraction layer. So you can add clients, and then as you carve out the pieces, you can gain speed And then eventually, you can take away the monolith because you've replaced all of the monolith functions with microservices. But it lets you eat the elephant one bite at a time.
Right, so I mean, think of the functions of things like database connections or Active Directory connections or SMTP or whatever your monolith is talking to. And then the adapters are basically service brokers for that particular service to interact with the client. All right, I think I went through that. So now that leads us to, once we know how we're going to decompose our app, we need to understand how we're going to deploy it. And so again, Mr. Cloud Architect, I leave it to you to talk through some deployment patterns.
All right. So there's a few. There's a lot of common ones. There's the cloud on a stick, which sounds about as good as if you get something else on a stick at the fairground. Having said that, it's a bad idea. And here are some of the reasons it's a bad idea.
So Christian, what are we looking at here?
But there are some benefits to this. I want to point out, first, there's an implicit assumption with these boundaries that there's no direct internet access into the cloud thing directly from the internet to the cloud thing, right? This is just creating a link to the data center via, whether it's VPN, some other kind of private layer 3 connectivity, something like that, right? This is a really common way of saying, I've got a thing that I want to put in the cloud, and I have all these data center dependencies, and I need to solve those. This fits into the category of unnatural acts. It's not that you can't do it, but it creates a tight coupling, and if you have any issues with your perimeter controls, you've created a new pathway into your data center. You've extended your enterprise edge, as it were, right? And the controls, your edge controls in clouds, are very different than your edge controls in data centers.
So in this example, we'd be hosting the front end of our application in AWS or something?
It could be that. It could be that you've got a little converter microservice or a converter function that I've got some XML and I need to turn it into a PDF document. I've got.
But the data is resting in our data center, and so we need to develop that relationship.
Right. Or I have dependencies. I might actually be willing to put some data out here, but the app that I'm running in AWS or in the cloud shouldn't. I'm using AWS icons.
As an example.
As an example. But that way, things in your data center can talk to your cloud app, and your cloud app can talk to things in your data center.
Okay.
It's an okay pattern to start to learn, but it isn't going to scale well, and you'll find a bunch of interesting problems. So let's say you want to actually serve internet traffic from your thing in the cloud. Well, you could add a backhaul pattern where you actually truck that internet traffic across the private link, which is also a bad idea.
Sounds like we have a lot of bad ideas.
I think it's the nature of architecture. So this has all of the practical upshots of the previous pattern with the added benefit of if you happen to get a particularly skilled attacker who knows how to abuse cloud-hosted environments, now if they manage to break into your app in the cloud, they can maybe, steal your role, and maybe if you did that badly, take over your account. Plus, you get all the latency of trying to serve internet clients across your private link. So then there's, well, let's solve that problem by sending the internet clients directly to the cloud thing, right? So in case you didn't catch it, there's the leak. What could possibly go wrong? So in case it wasn't already obvious, this is a really bad idea. All right.
Do we have any good ideas?
Funny you should ask.
Oh, okay. That wasn't set up at all.
Use clouds the way the cloud was intended. Clouds are meant to be decoupled. They're meant to be loosely coupled. They're meant to interact with things over web services. There's a reason all of the clouds have web service APIs and make assumptions about interacting with things over web services. They promote loosely coupled patterns. So the idea here, I've got a thing that I'm running in the cloud. It needs to talk to things in my data center, expose those things via an API gateway. Put the API gateway on the internet. Do all the things you should do with an API gateway that's on the internet. Do rate limiting, do throttling, do all of your authentication and authorization, do your checks, right? But let your cloud thing talk to your API gateway. It's going to take a little bit of work to expose stuff that way, but it's the right way to do it. There's also the inverse model. I've got a thing in my data center that needs to talk to things that I've put in the cloud. Just flip the model around, use API gateways in the cloud, let your things in the data center talk out your standard internet proxies to get to your cloud thing.
And you can just protect that internet traffic the same way you'd protect any other traffic. You could use, mutual authentication, or, several different.
This is fundamentally no different than talking to a SaaS, right?
Right.
You might subscribe to a SaaS something. Now your cloud app is just a SaaS to you. And then put it all together, right? If you need to talk both directions, set it up both ways. Use web service APIs the way cloud's intended. So this gets us
Right.
to...
So this leads us sort of to the end here, where we do have a couple of hypotheses that we want to just bounce off the group here. Our first one, Christian.
Oh, yeah. Speed is better than thinking about it. Clouds. You'll learn something. Find something that you can afford to make a mistake with, honestly. Find something small, something that you can afford to make a mistake with. Get out there, do it, learn it, make the mistakes. Have a few ground rules so that you don't make big mistakes. Because you're going to stub your toes on stuff. Every enterprise is a little bit different. Every business is a little bit different. We can give you guidelines on what mistakes you might make, but you're going to discover your own unique versions of those. And that's important because it's part of a learning pattern. It's part of how you instill the cloud lessons in the rest of the business. Because it's not just about getting a thing to the cloud, it's about building that organizational muscle to understand what it is to do things in the cloud.
Right, there's a lot of, the technology hurdles to getting into the cloud are nothing compared to your organizational changes and what is necessary to adopt cloud thinking but it's all intertwined. You can apply the same thing to like a DevOps mission as well. So if you wanted to automate your build chain, which a lot of us are trying to do, the natural places where we would have security gates and things have to sort of evolve. You have to change your way of thinking, and the organization has to change its way of thinking and its enforcement of risk and that sort of thing in order to keep up and evolve with the agility and speed of the cloud. And so our advice, like we started out with, is that you start with something small and make that initial deployment into the cloud and have that success, and then build on that using the same kind of method to deploy more and more applications.
The corollary to that is don't pick something trivial. Pick something that's meaningful. So you should be able to afford to make mistakes with it, but don't pick the little app in the corner that nobody cares about. Pick something that's meaningful that will get that you'll get some business value out of, because you want a value story out of it, right? You want to say, we moved this thing, it provided this value, we learned these lessons, and you build a success story around that.
All right, and then our second hypothesis is sort of mine, containerize it. So another issue that we have in the cloud is that your app may be commingled with a lot of other apps. And so in security, we would want to see some sort of formal isolation of those apps from each other so that they can't communicate with each other, or to limit the actual blast radius of some sort of event. So if a hacker got in, it would limit their ability to pivot if we could isolate these applications from each other. But
yeah. And I think you're hinting at a classic problem of data center apps, which is that data centers, I mean, this is going all the way back to the Jericho Forum stuff, right? But data centers, apps in data centers tend to have assumptions that they can talk to their neighbors, they can talk to things without too much challenge because there's implicit trusts there.
right. But as we've grown as an industry and everything, and as security has become more and more important with the types of breaches and things that we have standard bodies like PCI DSS, for example, where they come in and say, well, yeah, it'd be nice if on your cardholder network you're isolating servers from each other and
Right.
zones from each other.
Well, and the practical upshot of that is that you can move faster because if you contain things and you contain your fault zone, then you can make change faster, you can deliver value faster with lower risk because your risk of impacting other things around you is dramatically decreased.
So in a traditional cloud environment, there are several different ways that we can create this kind of isolation. Some of them are more expensive and difficult to do than others. I mean, we could implement virtual firewalls. We could implement physical firewalls and have multiple clouds, but all that starts sounding really expensive. And so we were talking about it, and we thought, there is a possibility that you could use containerization technology like Docker to create proper network or proper isolation by applying a network overlay to it, and then containing like your monolith app inside of that while you're working on decomposing it.
And do it in a templated way, and actually use the containers to help you abstract your dependencies, so that you relieve some of the problems of your monolith app.
Right.
So this is an idea that we actually wanted to bring it out, get a little bit of get some community engagement, some thought on. We think this is an area that's worthy of more research. So we wanted to share the things we've learned on our journey so far, and then also bring some ideas out. And others may be further along on this path than we are, and others may not have seen this yet. So we wanted to bring this out and have a dialogue about it.
Yeah, so the last piece I'll say about that, I mean, the reason we can create that isolation in a container is that we can first of all, limit the communication ports that the container talks on, and we can lock down the internal commands within the OS of that container so that it can only do the things that you're putting into it, only what it's supposed to do. And then further, you can apply rules like AppArmor or SE Linux to define what the kernel calls are doing and what the container is actually capable of doing from a kernel perspective. And so all of that together sounds like that you could create an adequate or at least compensating control for network segmentation or for isolation. So that's the hypothesis. Which leads us to the end.
Get involved, join the community. Have a conversation with us about it.